Hello class 10. Let's learn methods of solving pair of linear equations in two variables. Algebraic methods to solve pair of linear equations. The first method be substitution method. For this, let us take two equations a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 is equals to 0 and mark them as 1 and 2. Now from these two equations, let us choose any one equation and write it in the form where y is equals to in terms of x. So we can choose equation 1 and write as in the form y is equals to, take everything to the right hand side. Now since we have one equation in terms of y, therefore the next step would be to put that value or substitute that value of y in the other equation. So if we have taken from 1, now we will put those values in equation 2. So clearly we can see that if we substitute the value of y in terms of x from the previous equation in equation 2, then this second equation will completely become an equation in terms of x. So we'll gradually solve that equation to get the value of x and then substitute that value of x in any of these two equations to get the value of y. Let's see an example. Let the two equations be x plus 2y equals to minus 1, mark it as 1, and 2x minus 3y is equals to 12, let's mark it as 2. So by equation 1, we can write that x is equal to minus 2y minus 1. So we have represented x in terms of y. We have just rewritten the first equation and marked it as 3. Now we will put or substitute this value of x from equation 3 in equation 2. So we have got the expression of x from equation 1 and then we are substituting it in equation 2. When we put the value of x as minus 2, y minus 1, we will get everything in terms of y right here. Therefore, when we further solve it, we are getting the y as minus 2. Now, let us put this value of y in any of these two equations or equation 3, any one of them. So, if you substitute the value, we will get the value of x as 3. So, therefore, the final answer would be 3, minus 2 or x equals to 3 and y equals to minus 2. The second method is the elimination method. In this method, we have to eliminate one of the two variables to obtain an equation in one variable which can be easily solved. So what we can do here is we can multiply or divide the two equations with any number so that we can have any term which is common to both the equations. And after that, if we add or subtract the two equations, we will get the final equation in terms of only one variable, as we are eliminating one variable from both the equations. Therefore, we will be left with only one variable. So, let us take the example of these two equations. So, 3x plus 2y is equals to 11 and 2x plus 3y is equals to 4. Let the equations be 1 and 2. Now, to eliminate the two values, what we can do is we can multiply the first equation by 3. So if you multiply the first equation by 3, we will get this equation. So 3x into 3, that is 9x plus 6y is equals to 33, and we will multiply the second equation by 2. So we'll get 4x plus 6y equals to 8. So multiplying the first equation by 3 and the second equation by 2. So clearly from here what we can see is that plus 6y is a common term in both the equations. So when we multiply some particular numeric values, both can be multiplied by 3 or minus 3, anything you choose, or we can take separate numbers to multiply. But the main goal is to get similar terms in both the equations, just like this. So we wanted to get similar terms. So what we have seen here is that if you multiply this equation by 3, we'll get here 6y. And if you multiply this equation by 2 will get 6y. So common term is being obtained. Now we can subtract these two equations and we'll get something only in terms of x, and from there we can calculate the values. We could have also multiplied 2 in equation 1 and 3 in equation 2. If we would have multiplied 2 in equation 1, the first term would have been 6x, and if you multiply 3 in equation 2, we would have got here 6x. So what we can see is here also 6x is the common term that would have been obtained. In that case also we could have subtracted. But we can choose any method, but make sure either of these two terms will have common terms, not the constant, because we don't want to eliminate the constant, we want to eliminate any one variable. That's why we have chosen for this case to eliminate y. So the next step will be to subtract equation 4 from 3. So from 3 we will subtract equation 4. So when we do that, we are changing the signs. Okay, all of them were positive here. Now we are changing the signs as we are subtracting. So when we do that, we can see that 6y is getting eliminated. And now we are left with only x, only one variable. So we are getting the value of x as 20. 5 by 5, that is x equals to 5. Next, we'll put the value of x in the equation, in any of the equation 1 or 2, anywhere you can put the value. Now when we put the value of x here and further solve it, we can get the value of y. Now the value of y is obtained as -2. Finally, the value of x and y is obtained, and we can write down the final solution as x equals to 5 and y equals to -2. Equations reducible to pair of linear equations. Suppose we get equations like this, where the equations are not in terms of linear form. So if they are not linear, then we have to solve this equation by first transforming them into linear form and then solving it by some method. So to transform them in linear form, first we have to identify which are the parts of the equation which is not in the linear form. For this particular two equations, we can see here 1 by x and 1 by y. Again in this equation, 1 by x and 1 by y are not in linear form. Only the part which is supposed to be converted is 1 by x and 1 by y. So what we're going to do is, we will substitute 1 by x as u or p or q. We can take any variable, and we will substitute 1 by y as another variable. For this case, we are taking v. After that, we have to solve the linear pair of equations. When we substitute 1 by x and 1 by y as u and v, then we will get equations in linear form. Then when we get equations in linear form, we have already learned how to solve them using substitution or elimination method. We can use any of the two methods to solve these equations. Then we will put the values which we are obtaining for u and v after solving by any method and get the values of x and y from these two equations again. Take these two equations as 2 by x plus 3 by y is equals to 13 as 1, and 5 by x minus 4 by y is equals to -2 as equation 2. So first we have to transform them into linear form. So we'll substitute 1 by x as u and 1 by y equals to v, because see, we can see that 1 by x and 1 by y in both the equations are the terms which are not in linear form. So substituting these two values u and v in these equations 1 and 2, will get 2u. So 2 into 1 by x will be 2u plus 3 into 1 by y will be 3v, that is equals to 13. In the second equation, 5 into 1 by x will be equals to 5u minus 4 into 1 by v or 1 by y is equals to 4v. So that is equals to -2. 2. We'll mark 5u minus 4v is equals to minus 2 as equation 4. Now that we have got the two equations in terms of linear equations or pair of linear equations, now we have to solve it. So we can use any method, be it substitution or elimination. In this case, we are using the elimination method. So what we can do here is we have 3 and we are having here 4. So they are multiples of 12. So we can use 4 here. So we can multiply 4 in equation 3 and we will get the second term as 12v, and we can multiply 3 in the fourth equation and we will get it as minus 12v. So plus 12v and minus 12v. Clearly, if we add them, we can eliminate or subtract these two values. So we will be left with only u. So let's multiply this and we are getting the two equations. The equation 3 when multiplied by 4 becomes 8u plus 12v is equals to 52 from here. And if you multiply 3 in this equation 4, we'll get 15u minus 12v is equals to minus 6. Now that we have two equations and we can see that these two terms are same, only their signs are opposite. So in this case, we do not have to subtract. We'll just add them and then we can eliminate these two terms. Okay. So if you do so, we can see that by adding them, what we can see here is we are getting 23u is equals to 46. So if you solve it further, we'll get u is equals to 2. Next, taking this value of u, we can put it in this equations 3 or 4. So if you put it in equation 4, we can get v is equals to minus 2 minus 5u. U is 10, so minus 10. U is equals to 2, so 5 into u is 10. So minus 2 minus 10 by minus 4 is equal to 3. Hence, we are getting the value of v as 3. So we have got the solution of u as 2 and v as 3. But we are not supposed to stop here because the initial equation was in terms of x and y. We have got the values of u and v. So we must write the solution in terms of x and y. So whatever values we have got for u and v, we'll just substitute in this form. Okay. So we have 1 by x equals to u. So clearly we can say that u is equals to 1 by x. So let us put the value here. U is equals to 1 by x. That means x equals to 1 by u. So x equals to 1 by u means 1 by 2. And y is equals to 1 by v. That is equals to 1 by 3. Now that's the solution of this equations. Thank you everyone. Hope the video was helpful.